Hello everyone. So let's see how to solve today's question. So today's question is minimum divisions operations to make array non-decreasing. So let's go through the question description once. So you are given an integer array nums. Any positive divisor of natural number x that is strictly less than x is called a proper divisor of x. Okay. So for example 2 is a proper divisor of 4 while 6 is not a proper divisor of 6. So the greatest divisor which is not equals to the number itself is what we are calling as a proper divisor of x. You are allowed to perform an operation any number of times on nums, wherein each operation you select any one element from nums and divide it by its greatest proper divisor. Okay, so from the array you can divide any number by its greatest divisor, or what we are also calling as proper divisor. Okay, so in one operation we can do it. So we need to return the minimum number of operations required to make the array non-decreasing after performing these operations. Okay, so if it is not possible to make the array non-decreasing using any number of operations, then we need to return -1. So if we look at the test case, so in this, if you see, this is 25 and 7. So for 25 and 7, this 25 is if greater than 7. So we need to reduce it down. So the greatest divisor of 25 is, I think, 5 only, right? So it's 5 only. So if we divide it by 5, so we get 5, and then 5 is less than 7. So this array becomes non-decreasing. Then if we look at the second example, this is 776. So in this 776, this is not decreasing. So we need to make it non-decreasing. So if this 7 is equal to 7, no problem. But this 7 is greater than this 6. Okay. So we need to solve it. So as the 7 is greater than 6, we need to divide the 7 by its proper divisor. So for 7, the proper divisor do not exist. Okay. So we cannot divide it. So the result will be -1 because we cannot solve for these two. Okay. So for this test case also, for 1, the proper divisor do not exist, which is less than 1. So that's why we are just returning 0. So because this is already like in a non-decreasing way. So if you see, this one is equals to 1, this one equals to 1, so this is non-decreasing only. So okay, so now if we look at this approach for this problem, so first of all, like if we see, for every number we need to find its greatest divisor, which is not equal to that number. So finding that like can be a root n operation. Okay, so we will be iterating from like 2 2 till root n. So if we find the number which is divising our current number, so we can get it as the proper divisor. We can get it as a proper divisor. So we can do it in root n. But if we see at the constraints are the nums dot length is till 10 to the power 5 and nums of 5 can be till 10 to the power 6. So if we see this constraint, so if we go ahead and for every number, if we compute its proper divisor by the root n approach, so this will be n root n. So n is 10 to the power 5 and root n will be around 10 to the power 3. So this is 10 to the power 8. So this will just barely pass. Okay. So this is just on the borderline. So we need to think of some better way. Like this can also pass, but this will be just on the borderline and we can have issue with it. Okay. So we will see another way of finding the greatest common divisor, which will be in a lesser time complexity. We will pre-compute the proper divisor. So suppose if by some mechanism, if I have the proper divisor with me, so then what I can do is I can just iterate over this array, and for every number, I will check if it is greater than its next element. So I'll try to divide it by its greatest possible divisor, and then I will add that operation in my answer, and this will give me my result. So now, if you look at this example, let's see for this example the things. So see, if for this 25, for this 25, I see this 25 is greater than 20. This 25 is greater than 20, so I need to reduce it down. Okay, so to make it non decreasing. So for 25, what is its greatest divisor? It is 5. Okay, so if we divide it by 5, this will be 5, and then I'll say I will add 1 in my operation. Then this becomes 5. So now for this 20, I'll see if it is satisfying things with the next one. So for this 20, if I see this 20 is greater than 5, so this 20 is greater than 5, so I need to reduce it down. So I will reduce it down with this proper divisor. So the proper divisor is nothing but 10. 10 is the greatest divisor, lesser than this 20. So I will reduce it down by that. So this will be 2. The when divided by 10, this will be 2, and then it will look like this. So now if you see, when I was trying to resolve things for this 20, the things broke for the previous element. Okay, so things broke down for the previous element. So that's why we cannot just iterate forward and just keep reducing it down, because the things can broke for the previous ones. So instead of that, what we will do, because if we go ahead and if we add one more operation for this, so this is reduced down. So then if we go ahead and also check for this last two, this 5 and 10, this 5 is less than 10, so there is no issue, so this will be as it is. So based on this our answer will be 2, but the correct answer is -1, because you see this 5 is still greater than this 2, and this yes, so this 5 is greater than 2. So this, because of this answer will be -1. So what we will do is we will iterate from the back. We will iterate from the back, because if we have solved things down from the back, we will know like things are fine till over here. Over here these are fine from ahead ones. So I'll just check. So I'll try to reduce it down as much as I can, while I have reduced it as much as I can from the end. Okay, so as much from the end as I have reduced it down, so I will try to reduce it down even lesser than that. Okay, so now if you see, if we iterate from the back, so for this 10 and 5, I will see this 5 is lesser than, so no need. This can be as it is. For this 20 and 5, as this 20 is greater than 5, so this will become 2 by after dividing by the proper divisor. So don't worry, we will see how to get the proper divisor. But for now, just think we have the mechanism by which we can get the proper divisor. So this will become 2. And then after that, this is 25. So this 25 is greater than this 2. So what we will do, we will try to reduce it down by its proper divisor. So this will reduce it down to 5. But as even after reducing it down, this is still greater than this 2. So the answer will be -1. Okay. So that's how we'll be doing things. So yeah. So let's see in the code. We will just do it greedy way only. So our code will be of the time complexity of somewhat n log n. We will see. Okay. So let's go to the code and we will see like how we are doing things. So what I'm doing over here in the code is that, first of all, I'm getting the maximum number. So okay, so I'll be pre-computing things for all the numbers present in my array. I'll be pre-computing their greatest divisor, their proper divisors. Okay, so I am getting the maximum element. I am creating a divisors array for this maximum number, and then I'm just setting the divisor for each of them as them itself. Okay, so for 2, the divisor is at least 2. So 2 is the known divisor. So for them, I'm just setting all the values as the number only itself. Okay, so then what I'm doing is that I'm iterating over all the numbers from 2 till the maximum number present in my array, and I'm just setting the greatest divisor for that number. Okay, so for this two, I'll come down. I'll iterate on all of its multiple which are lesser than my maximum number, and for them I'll say for you, as of now, the maximum divisor is I. Okay, so for you the maximum divisor is I for now. So this so we need to just generate this for all the numbers. Okay, so if we take a dry run, so let's say if we have chosen like 3, so for 3, 3 will mark down, 3 will mark, let's say 3 will mark 6, 3 will mark 9, 3 will mark 15. So for now, for this 15, the proper divisor will be 3. But then what will happen? Then we will iterate on to 4, we will go to 5, and then 5 will mark that 15 as like 5 is the divisor for this 15. So then 5 will mark it down. So I'm just generating all the possible divisors, and I'm just marking the greatest divisor. So whichever will be the last divisor dividing me, which is lesser than my value, will be my divisor. Okay, so that's the thing. So what will be the time complexity of this? This will be around n log n. This is somewhat sieve kind of a way. So for each iteration, I'll be doing like this max number divided by I. So this will be like max number divided by 2, max number divided by 3. This will be max number divided by 4. So this will be nothing but max number into 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5, like this. So this will be max number times log of max number. So if you see, this will be 10 to the power 6, as the max number can be till 10 to the power 6 into log of this 10 to the power 6. Okay, so so that's why we are good with our time complexity, because log of 10 to the power 6 will be a lot less. So we are good with that. So then what I'm doing is I'm just taking a result. I'm marking my result as 0 for now. Then I'm iterating from the end. As I told you, we'll be iterating from the end, and I'm just checking if my current number is greater than the next number. I'll be dividing it down. And I'll be just checking if my divisor is equal to my number. So for 7, so for 7, the greatest divisor will be 7 itself. Okay, so in that case, I cannot reduce that number down. So in that case, I'll be returning a -1, or else I'll be just reducing down my number with the greatest proper divisor. So there will be only one operation per number, because after dividing that number by its greatest possible divisor, the number will reduce it down to the prime number. So the prime number, it will reduce it down. So if you take an example, like if you see 20, so when I divide 20 by this greatest divisor, which is less than 20, it is 10. So after divided by 10, we get 2. So 2 is a prime number. So then this 2 won't be able to divide further. So there will be one operation per per number. Okay, so I'm just checking that if my current number is greater than the next number, I'm just getting the divisor. I'm checking if my divisor is equals to my number, then I'll be returning a -1, or else I'll be just dividing it down by the greatest possible divisor, and I'm just adding this operation in my answer. So even after even after it is divided, if it is greater than my next number, so I'll be returning a -1 in that case also, or else I'll just continuing things, and in the end I'll be just returning the result. So this is just a O of n loop, and our above one was O of n log n loop. So so time complexity wise we are good, and the space complexity for us will be O of maximum, because we are generating the divisor still maximum. So the space complexity will be O of maximum. So yeah, that's about it. So we did it in a greedy way, and we were able to solve it. So yeah, I hope I was able to make you understand the code and logic. So thanks.